Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next module. Problem number 11, fluid mechanics. Okay. As usual, first we come towards statement. Problem number 11, fluid mechanics. Okay. A bottle has a mass of 35.00 gram when empty and 98.44 gram when filled with water. When filled with an other fluid, the mass is 89.22 gram. What is the specific gravity of this other fluid? Okay. This problem is entirely related to specific gravity. Specific gravity of any fluid is the density of that fluid divided by density of water. Okay. This fraction is actually specific gravity. Okay. Quite not difficult, quite simple problem. Now we come towards solution. Okay. First we make some denotions in order to make our formula clear. Okay. Let specific gravity of fluid is denoted by capital S, capital G fluid, where fluid is written as a subscript of G. Okay. Let specific gravity of fluid equal to Sg fluid is to be determined. Therefore, it is written equal to sign of interrogation. Okay. Now, volume of water is equal to V water, where water is written as a subscript of V. This is again equal to sign of interrogation because it is also to be determined, to be known. Actually, dear students, we are not concerned with determining the volume of water, but it is a part of our sequence. Okay, and our problem becomes much easier if we follow a proper sequence. Okay. Mass of water is equal to small m water, where water is written as a subscript of m. Mass of water is equal to 98.44 gram minus 35.00 gram. Okay. Because 35 gram is the mass of a bottle, while glass mass is 98.44. So net mass, that is subtracting the mass of bottle, mass of water will become equal to 63.44 gram. Is alternatively equal to 0.06344 kg. Okay. What we have done? What we have done? We have just converted gram into kilogram. Okay. Because, dear students, in a kilogram there are 1000 grams. And when we are moving from smaller unit to bigger unit, then we have to divide. And when we are going from bigger unit to smaller unit, then we have to multiply. Okay. So when we are going to convert gram into kilogram, then we will divide it with 1000 and 63.44 gram will be equal to 0.06344 kilogram. Now we come towards mass of fluid. Mass of fluid equal to m fluid, where fluid is written as a subscript of m, is equal to 89.22 gram minus 35.00 gram. Okay, because 35 gram is the mass of bottle, while 89.22 gram is the grass mass. So net mass of the net mass of fluid will become equal to 54.22 gram. Okay, because 89.22 gram minus 35.00 gram will become equal to 54.22 gram, and it will alternatively become equal to 0.05422 kilogram. Okay, because we are moving from smaller unit to bigger unit, so we will divide it with 1000, and hence 54.22 gram will become equal to 0.05422 kilogram. Now, density of water equal to rho water, where water is written as a subscript of rho, is equal to mass of water over volume of water. Dear students, actually density of water is given in the table of densities, and we can take that value directly, but we will write it in this way. Okay, here, because density of water is given in the table of densities, which is 1000 kilogram per meter cube. So here we have written that value in place of rho water, and this is equal to mass of water over volume of water. So mass of water we have calculated in the previous page, this. Okay, 0.06344, 0.06344 kg. Okay, mass of water equal to 0.06344 kg. Okay, mass of water over volume of water. From here, volume of water will be shifted on other side of equality, and it will become in a numerator, and 1000 will become in the denominator, and volume of water will become equal to 0.0006344 meter cube. Okay. So, as I have previously mentioned, that we are not concerned with the volume of water, but as a part of sequence, we are determining volume of water, because the other fluid whose specific gravity is to be determined, we will take equal volume. Okay, so when we have calculated volume of water, we will take same volume of the other fluid. Okay, let us take equal volume of fluid and water. Hence, volume of water equal to volume of fluid equal to 0.00006344 meter cube. Okay. Dear students, specific gravity is capable of being determined when we take equal volume of both fluids. That is, first fluid is water and the second fluid is other fluid. Okay. Now, specific gravity of fluid, which is denoted by capital S, capital G, fluid, where fluid is written as a subscript of SG. Okay. Specific gravity of fluid is equal to density of fluid over density of water. This alternatively becomes equal to rho fluid, rho F over rho water. Okay. Now, density of fluid is equal to mass of fluid over volume of fluid. Similarly, density of water is equal to mass of water over volume of water. Okay. Dear students, here in this way, both volumes will be cancelled out. Okay. Because in the next step, it will become 0.05422 kg over 0.000634 meter cube multiplied with 0.000634 meter cube divided by 0.06344 kg. Okay. In this way, both volumes will be cancelled out, which are exactly equal, and kg will be cancelled out with kg, and hence specific gravity of fluid will become equal to 0.8546658. Okay. From here it is quite clear that specific gravity has no unit. It is just a number. Okay. So, this is the solution of our problem. We have find out our solution of this problem. That is to say, specific gravity of fluid has become equal to 0.8546658. And it is our discretion that we can restrict it only to 2 decimal places. Okay. In which case it will become equal to 0.85. Okay. However, this longer figure is also quite acceptable. Now we move towards table. This is the table of densities, from where density of water is given as 1000 kilogram per meter cube. Okay. It was used in our in solving our problem. Now we come towards reference. Okay. To this extent our problem is has been solved 100%. And from this table only density of water was used. Now we come towards the reference book. Reference book from where this problem has been chosen is Physics for Scientists and Engineers with Modern Physics. Its author is Douglas C. Giancoli, its publisher is Pearson, and its 4th edition, having been published in 2009, has been adopted or followed, and its chapter number 13 under title Fluids is our concerned chapter. And this problem is enumerated at serial number 5 of the exercise of this chapter, that is module number 5 of the exercise of this chapter, that is exercise number 13.5. and this is the end of our module. Okay.